7. We have been working on 9.6 counting principle because we needed to figure out that stuff for probability. Now, probability problems can get pretty in-depth. Okay, probability, what is it? It's the chances of something happening, right? How likely is something to happen? It's a percentage. It is a decimal. It is a fraction. It's all of those things. Your test grade is basically a probability, yes? How many you got right out of the total number, if it's calculated that way. So when I'm thinking probability, I want the number of things I want in the numerator, right, out of the total number of things there are. Well, do you need to have probably the combination and permutation when we get to hard things to do that? Yeah. So that's why we did that first. There was a reason. Okay, so we have things, any happening for which the result is uncertain is called an experiment. We experiment all the time. We do experiments all the time. The possible result of an experiment is an outcome, and the set of all possible outcomes of an experiment are a sample space. So a sample space is the total number there is. Outcomes is what we're looking for. And sometimes people try to mush those two together, okay? So that's the big thing. Sample space is everything out there that I can possibly have in that situation. Outcomes are what I'm actually looking for. Subcollection of the sample space are events and outcomes. Events and outcomes can be the same. Okay, find the sample space for each of the following. So, one coin, if I toss a coin, what's my sample space? If I toss a coin, what are my options of seeing? Heads or tails. You were doing probability already. Okay. If I toss 2 coins, what is my sample space? Heads, tails, heads, and tails. Does it matter which order I put those in? No, I just put them in that order. Okay, if I do 3, heads, right? Heads, tails, heads, tails.
Times 3.
No.
Or not.
Then tails, heads, tails. And tails, heads.
Tails.
Oh, we did tails yet?
THH.
Oh, we forgot a THH. I think so. Okay, now we listed them out. You know how I'm going to check? Got 3 spots, yes? 3 spots?
Yep.
What is my choice for this first spot? How many?
2.
2, heads or tails, yes?
Yeah.
Well, you got 3.
2.
2. And 2.
What?
Which is 8. Is that how much we got?
Yeah. So why did we take the extra step and do all that? Because Kaylee, we're gonna have to.
Okay, there are times that you're just going to list them. If I told you that, you guys probably would have just listed them, correct?
Wow. Yeah.
Okay, but when I give you 6 coins, are you going to list them? No, because that would be 2 to the 6th, right? And it'd be 64. I don't want to list out 64. Do you?
Yes.
Depends on the day.
Yeah, it depends on the day what I'm trying to avoid, correct? Now, am I going to probably skip 1 or 2 when I have 64 I'm trying to get? Probably. Okay, so a sample space is what I could possibly get. Remember, that's anything I possibly could get. A probability of an event, I've already talked about this. The probability of an event is the total number of the events over the same what you're looking for the event and the total sample space. So when I wanted a certain throwing a cone 3 times and getting a certain specific thing, right? Like 2 tails. That's my event that I'm looking for, right? But my sample space was 8 because that was how many different possible setups I could get. So favorable over total. And you've been doing probability a long time, haven't you? Yep. I'm just going to make it harder because I'm going to give you harder situations. I'm not going to give you the probability of picking a girl out of a room of 13 out of here.
Wait.
That'd be easy, right? How many girls do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 9, 10, 11, 12, 13, 14. So it'd be 9 over 14. And that's your probability, right? That's pretty easy. We're going to get more complex probabilities.
Why?
Because life is probability.
Oh, I want everything.
You know, right now we have a probability of dying, just so you know.
There's a probability of other dimensions. We're making other.
We don't need that?
It's the same thing.
I see
The
those
chances are
videos
infinite.
on TikTok where they're like the percentage of like when you're close to like danger zone.
Okay, I'm going to tell you almost any scenario that you can come up with has a probability of happening except for like completely unlikely things. Okay?
Riley driving a paramotor flying.
Yeah, that probably is
What's
zero.
That could happen.
Okay, so we have things that are certain and things that are impossible. It is certain that someday I'm going to die. Yes?
Yes.
Yes.
Maybe not.
The probability of me dying today is probably a little bit less than when I'm 80, right? But someday I'm going to die. So that is a certain event.
Am I invited to your funeral?
Sure.
We all are.
I'm gonna have an exclusion list, CJ. I'm starting it now. Your name's the first one.
If you're
Yeah,
not,
the front
if
row.
I'm not going
No,
to, you won't be
exclusion.
at mine.
Totally.
Okay.
I'm gonna start tearing up over the fact that you used to make me do math.
You have to wait outside of the.
You're gonna stand out there and say you're.
Hey, I'm not going to yours because you won't be at mine.
I'm gonna have.
Hey, maybe I will. I don't want to be at yours.
I'm gonna have.
I want to die
microphone,
first.
And I'm gonna be yelling all
Okay.
the things that she taught me.
She's gonna remember them all.
Try to.
Okay, guys, let's stay on task. We're so off task today. Okay, so something that's impossible, never going to happen. I am not going to turn into a desk. No. Okay, so I am not going to turn into a desk. That is impossible to happen. I am not going to flip a coin and get a number 2, am I? No. If I'm going to flip a coin, I'm going to get heads or tails. If I'm going to roll a die, unless it's a different kind of a die, I'm going to get 1 through 6, correct? They are going to tell you different kinds of dies because there are, but there are certain things and there are impossible things and everything between, okay? Equally likely, flipping a coin and getting heads or tails, right? If 50-50 is equally likely. This is just a thing we need to know. If it's always going to happen, eventually going to happen, it's going to be certain, impossible, and most things land somewhere in between there. Okay? 2 coins are tossed. What is the probability that both land heads up? So, I got 2 things happening, yes?
20.
And my outcome is a head, right? Over how many possible? 2.
Yeah.
And then I'm going to do it again. And I need a head over how many different outcomes?
2.
2. So what is the probability?
1 in 4.
1/4.
That's confusing.
Why?
I don't know.
Okay, the reason why it's not a half anymore is because I didn't say 1 coin, I said what?
2.
2. Is the probability going to go down the more, or, yeah, because 1/4 is less than 1/2. It's the more exclusions I put on there or conditions I put on there is my probability going to go down. Yes. Okay. Now there's lots of things in statistics that's really funny because they'll say I'm 95% confident that this is going to happen. And somebody's like, oh, okay. And then somebody else says, I'm 98% confident that this has happened. And they're like, ooh, I like that better. Which one is actually more accurate is the 95. Because what happened is the 98 person got a bigger bucket. And if I am I trying to catch water out of the sky and I have a little cup, am I going to catch a lot less than if I get a pot? Yeah. So when you think about those things, you got to think about how much of my number line from 0 to 100 I'm getting.
How big
So-
a bucket do I want?
A card is drawn from a standard deck of cards. So how many are in there?
52.
52. 52. What is the probability of getting an ace?
1
One out of 13.
How many aces are there?
4.
4. How many cards are there?
52.
52.
One out of
And we
13.
have to reduce to 1 out of 13. Now, if you've done these a lot, you would have just said 1 because there's 1 ace in every, right? And there's 13 cards. So, but a deck of cards can be reduced by 4 because there's 4 of everything.
Yeah.
So, if you've done a lot of these problems, you start just going straight to 13 when it asks for things like that. Because there's in one suit, there's 1 ace out of 13 cards. So, but that's what you do. What you want over the total possible, correct? That's it. Now, if I would have said ace of hearts, I would have had a different answer, right? How many ace of hearts are there? 1 out of 52. So my probability of getting an ace is much better than getting my probability of getting an ace of hearts, correct?
And if it was an ace of hearts and diamonds, it would be 2.
Well, if it's hearts or diamonds, I can add them. It would be 2 over 52. But if it's hearts and diamonds, I'd have to multiply them, so it gets 1 out of 52 squared. So, whew.
Yeah.
And that's maybe not quite today. Tomorrow. Okay, 2 6-sided dice are tossed, and if it tells you no different, it is a normal die. So don't start getting all funky with your thoughts. Okay. As 2 6-sided dice are tossed, what is the probability that the total on the dice is 7? Okay, so on a die, how can I get 7? Because I need to know how I can get 7. Yes.
A 1 and a 5, or 1 and a
6.
6.
1 and a 6, 6 and a 1, 2 and a 5, 5 and a 2.
3 and a 4, 4 and a 3, 7. Just kidding.
Is that it?
Wait, this is a both dice?
Yeah, because I have 2 dice. To get 7, I'd have to do 2 dice, right?
She meant to do 6.
Okay. So I have 1, 6, and then, oh,
You meant to do
yeah, I meant to do this. Okay, so then, I think we got them all, don't we?
Yeah.
Okay, so how many is that?
That is 6.
6, okay? So there's 6. How many die do I have?
2.
2. So that would be 6 times 6,
Why would it be 6 times 6?
Because you have 2 dice.
because you have 2 dice.
So then it's just 6.
Because when I roll a dice, how many possible things can happen?
36.
No.
6.
6, right?
What?
When I roll a die, I can get 1, 2, 3, 4, 5, 6.
Yeah.
Yes. So I roll 1 die and I have a choice of 6 numbers. I roll another die and I have a choice of what? 6 numbers. So I have 6 and 6, which would be 36. Well, in this case, I'm not even going to multiply it out, am I?
It's just 6.
Why would it just be 6 times 2? That's my question.
Because you have 6 and you have 6, so it's 6 times 6.
Oh.
You have both.
Going back.
Connor, you can put your mask on.
Yeah.
Okay. It's because you're doubling your I know what you want to do 12, but it's not. I don't have a good word to tell you. Now, if I had something, that wasn't a good one. I wish they would have given us something that only could happen, I don't know. Is there something that could happen? 12. What if I ask you 12?
What for what?
The same question. I want the sum of 12.
You want 36.
How can I get 12?
6 and 6 and
6 and 6?
6 and 6.
No, 6 and 6 and 6 and 6 are the same.
Yeah.
We talked about that, right?
So
Oh.
1.
Just 1?
Yeah, just 1.
1 over 36.
1 over 36.
Whoa, look at that.
Because there's only one way that I can get the sum of 12, right?
Yeah.
So could I ask you for all sorts of different sums?
Oh.
Okay, what about the sum of 15?
It's not possible.
So what is the probability?
Zero over 36.
So I
What
need
is
it.
zero? So that is impossible.
So basically, since it's 36 because it's like 36 different combinations you can
Yes,
do with both of
yes,
them. Okay.
Yes. Okay. Now we got another one. Ooh, we get to play the lottery. In Arizona, the pick game, a player chooses 6 different numbers, 1 from 44. If these 6 numbers match the 6 numbers drawn in order,
In any order.
oh, in any order.
Way to point it out, Riley.
Thank you. Okay.
What is stick food?
Okay, by putting any order, what did it do to my chances?
Made it go down.
Made it go down, right? If it was in order, well, not chances, there would be more possible things, right? That's what I meant to say. Okay, a player wins the top prize if all of them match in any order. What is the probability of winning the top prize
Oh,
if a player buys 1 ticket? 1 ticket. Okay, so how many am I choosing? 6. Okay,
Different.
yes. 6 different
I
numbers.
want to do this one. Let's just
So
do
I
this
need
one
a
right
top and a bottom, right?
6 over 44.
So on the bottom is 44, right?
Yes.
Is it permutations or combinations? Does order matter? Order doesn't matter.
It doesn't matter.
So it's
Permutation.
Permutation.
I thought combination.
combination, order doesn't matter.
Man, that's rough.
How many are we picking?
6.
6.
4, 2, 6. 44.
Okay.
I don't know what goes on.
Okay. That's what we're like, ooh, what goes on top? Well, I only have how many numbers?
1, because you only buy 1 ticket.
I have 1 ticket,
And there's only one top prize.
but you have
have 6 numbers.
6 numbers. So you can have 6 numbers in any order, yes?
Yeah.
So
And that's your 44, 2, 6.
that's not your 44. This is my total. I only have 6 winning numbers, right? So 1, 2, 3, 4, 5, 6. How many choices after
44.
these? After these have been picked, how many choices do I have for my first number?
44.
After these 6,
38.
listen again. I have 44, choose 6 on my bottom, yes?
Took 6 away.
Shh. That tells me how many different combinations, groups of 6 I can make, yes? I have picked my 6 numbers. I have them written down on my piece of paper, right? Okay, over here, how many choices do I have for this first number to get these 6?
38.
Oh my
6.
God.
I said that, and
I
you kept going.
No, everybody was saying different things. I want everybody.
Okay.
Okay, people were saying different things. I want everybody on the same page.
Well,
Okay,
you put me on a different page. I got confused.
okay.
Took 6 away.
Why do I have 6 choices?
Because you only have 6 numbers.
Because I only have six right numbers,
Then
correct?
5, then 4,
Then 5, then 4, then 3, then 2,
I
then 1. So
said
it's
that.
what?
I said 6 exclamation mark.
Okay, I didn't say you were wrong.
We just were yelling over you, so she couldn't.
Okay, so I had to use different methods to find my numerator and my denominator, correct? So what I'm getting at is it one problem when I start? It's actually 2. I need to figure out what my total sample space is and what my event is. Got it? So 44 choose 6 is going to be 44 factorial over 44 minus 6 is 38,
I think.
and then 6 factorial, correct? And just for time's sake, I'm going to throw up my calculator real quick. Does that work for everybody?
No, she actually does not.
Yeah, I'm just going to do it in my head. Oh, I don't know how to do it? Is that what you said?
Yeah, that's why you have to grab it. You have to grab it.
Okay, so my denominator is 7059052. 7 million different combinations.
Tara, do you not do the 44, 43, 42, 41?
I did this whole, I did this in my
And then
head.
you're just gonna divide it after?
Okay, so now I have to do my numerator. 6 factorial, right? I think it's 720. Pretty sure. Okay, so 720 divided by 7059052. Now, I can make this a fraction and I can reduce it. My calculator will do it for me. Oh, it won't even do it for me. Okay, so it won't, when I hit fraction, it puts it in an exponential notation. It is, I need more room. This answer up here is 1.019966987 times 10 to the negative 4th. So I need to move this how many times?
1 to the negative 4.
So right here. So what is my probability,
Oh, that's like near impossible. Near.
okay? So is that why the lottery goes so many times without somebody winning it?
Where did you get this long, this whole thing from?
I put this in the
Is the
calculator.
probability 0.0001?
Hmm?
Is the probability 0.0001?
Yes. But it's the whole thing. Guys, sit down. The bell hasn't rang. People are behind you are writing. Okay, now you would reduce this and leave it as a fraction. Okay?
Just leave it as a fraction?
Yeah, but reduce it at least by 2.
We'll think about it.
Yeah.